Hello everyone and welcome back to J1 Aviation. So in this channel we like to review topics and questions around the FAA Private Pilot Knowledge Test. So today we're talking about ground effect. So what is ground effect? Is it a cushion of air that gets trapped between the wings and the runway as the plane gets close to the runway? Well, that's what it feels like. So to understand ground effect, let's back up a little bit and look at wake turbulence, because most people have a good understanding of wake turbulence. The origin of wake turbulence is that the wingtip vortices are being produced by the wings. They come off the wingtips in a circular motion. So how wide are these vortices? They're about one wingspan. So understanding the vortices that come off of the wing is a little bit of a prerequisite to understanding ground effect. So as these vortices come off the wing, they descend, right? And then this angling down off the back of the wing, that's known as downwash. So because the relative wind off the back of the wing is pointing down, this causes the lift vector to point back a little bit more, and this is induced drag. So you would have the lift pointing perpendicular, but then because of that downwash coming off the back of the wing down a little bit, the lift vector is pointed back a little bit, and that's the induced drag. So induced drag is that byproduct of a lift that's being created by the wing. So now that we understand that, let's see how this causes ground effect. So when you're flying, these vortices are able to make full circles around the wing, and the induced drag is fully impacting lift. However, when you are landing and the aircraft is getting close to the runway, these vortices start to get blocked by the Earth's surface. So as you are within one wingspan of the ground, the entire vortice isn't wrapping around the wing anymore. The outer edges of that vortice are being impacted by the ground, and they're being sent elsewhere by the surface of the Earth. Now, because all of that vortice isn't coming around the wing and causing the full downwash, that induced drag the vortice and downwash was creating is being reduced. The relative wind off the back of the wing is now becoming more parallel with the wing. And that lift vector is now becoming more vertical because there isn't all that drag pulling it down and aft. And this causes the aircraft, as it continues to get closer and closer to the runway, more of that vortice is getting stopped by the ground, and the drag is becoming less and less. And all of this causes the aircraft to float then as you get nearer to the runway. So all of this is well and good, and it allows you to touch down at a slower speed. But now on takeoff you need to be careful, because the opposite is true. So as you accelerate down the runway, the wing is continually creating more and more lift. However, the induced drag that should be there isn't, because the ground effect is keeping the induced drag low. So the aircraft thinks that it's ready to fly and could become airborne before a safe takeoff speed. Now, this is actually desired in a soft field takeoff scenario, but it's important if you become airborne at this point, you push the nose level so you continue to fly and gain speed in ground effect, not climb out of ground effect at that low of a speed. So remember, you can't climb out of ground effect at that low of a speed, because if you do, the vortices are then able to start making their full rotation, wrapping around the wing, causing the full induced drag, and the downwash and the lift vector will again be starting to point back, and you won't be getting the full upward lift that you need. And this could cause the aircraft to settle back into the ground effect, or worse, settle back onto the runway. So with that introduction in mind, let's look at some potential questions on the knowledge test. So the first one, what is ground effect? So the correct answer here is A, the result of the interference of the surface of the Earth with the airflow patterns about the airplane. Remember, as a wing encounters ground effect, there is a reduction in downwash and wingtip vortices. This results in less induced drag. Therefore, for any given angle of attack, the wing will produce more lift in ground effect than it does out of ground effect. So question number 2, floating caused by the phenomena of ground effect will be most realized during an approach to land when at And then the correct answer here is A, less than the length of the wingspan above the surface. And it becomes more pronounced as you get closer to the runway. So about 1 wingspan above the runway, the reduction in induced drag is only about 1%. About a quarter of the span, the reduction is a little less than 25%, and about a tenth of the wingspan, so just a few feet off the ground, the reduction in induced drag is almost 50%. So large reductions in induced drag can happen very close to the ground. Question number 3, what must a pilot be aware of as a result of ground effect? So for this one, the answer is B, induced drag decreases, therefore any excess speed at the point of flare may cause considerable floating. So this is one of the reasons why speed control is important upon landing. With excess speed, the aircraft will float down the runway due to less induced drag. Not so critical if the runway is 10,000 feet long, much more critical if you are operating on a short runway. Question number 4, an aircraft leaving ground effect during takeoff will B, experience an increase in induced drag and a decrease in performance. So remember, in ground effect, the induced drag is reduced, and this allows for more lift being available. So leaving ground effect on takeoff, the opposite will happen. The drag increases and the performance decreases. So then the last one here about ground effect. Ground effect is most likely to result in which problem? And the answer here is B, becoming airborne prior to reaching the recommended takeoff speed. So due to the induced dragging ground effect, the airplane may seem ready to fly well below the recommended takeoff speed. However, as the aircraft climbs out of ground effect with a lower than recommended speed, the increase in induced drag may initially result in poor climb performance. In extreme cases, the aircraft could settle back onto the runway after initially being airborne. So there you go, a little information about ground effect. Hopefully something there was helpful as we all try to become better pilots. So thanks everyone for riding along today. We'll hope you join us on a future flight, and thanks for flying J1 Aviation.